All right. Hello, Jacob. Thank you for joining us. Another episode of Bytetalks. Yeah, welcome.
Thanks. It's good to be here.
Well, to kick us off, why don't you do a little intro for yourself?
Great. Okay, yeah, absolutely. So I'm Jacob Matson. I work in DevRel at MotherDuck, um, which is a cloud data warehouse built on top of DuckDB. Um, my kind of or I would say I come into kind of data in a very earnest way. What I mean by that is I actually started in accounting, and as it turns out, if you apply some of those concepts to bigger and bigger calculators, you can do very cool stuff with data. And so that's how I got here.
There you go. You started with small data, and now you're back in small data.
Well, I
No.
think what happened is our computers got way bigger.
Yeah, yeah, yeah. Small data is not what it used to be, you know?
Yeah, correct. Right. I think I remember like Jordan, the CEO at MotherDuck, telling a story about like, in 2005 or something, getting like a 10 gigabyte data set and being like, hey, I like analyze this data set. And he's like, well, I have to spin up cloud resources to do it. Now it's like no sweat on local, right?
Yeah.
So
Yeah, you're like,
yeah.
I gotta like break into the supercomputer at the local university.
Yeah, exactly,
Oh.
exactly.
Cool. Well, I think it would be cool, maybe to learn for people listening to learn who aren't familiar with DuckDB, maybe learn a little bit about DuckDB and then what differentiates MotherDuck from DuckDB. So maybe we can go there next.
Yeah, absolutely. That sounds like a great place to go. DuckDB is a in-process analytical database, and it's MIT licensed, and so it's open source. And what that means is you can kind of put it anywhere, you can reuse it, you can extend it, and it's installable in a single binary, which is really neat. So you can kind of use it anywhere. Um,
That's actually one of
so
my criteria for like what I'm going to build with is like, is it a single binary I can just like install and run on my local machine?
yeah, totally right. Which means that uh, yeah, there's less dependencies, right? You just kind of it's all packaged nicely. You just download the file and unzip it, and you're good to go, right, for the command line. And of course, they've packaged it for Python as well, which is great. Which means you can get a full kind of analytical database straight in on your local machine with like pip install duckdb, which is like crazy. I mean, I
Wow.
remember like the early days of like learning to use a database, and it was like, okay, well, there's a big server over there. We can't give you access to that, but we can give you this client, and you can use that. And it's like, okay, well, how do I like learn this on like non-production database? And it's like,
Yeah.
good luck. Like,
Yeah. Yeah. Yeah.
so now, yeah, it's excellent from that perspective. Um, and one really cool thing about it is everything's kind of vectorized in the DuckDB engine, so it's very fast. It's built around kind of this parallel execution framework called morsel-driven parallelism, and that piece of it kind of lets it do things that are very hard to do with alternative engines. And so
Hmm.
um, that's all kind of like baked in. You just get it when you run a query. Basically, when you run a query on DuckDB, it's going to use all available cores immediately. And so that's a little bit different than maybe other databases. If you're familiar with kind of transactional databases where you can run 10 or 20 or 100 queries at once. DuckDB says, no, we're just going to take that one and we're going to split it into a bunch of small parts and jam it through your CPU as fast as we can. So MotherDuck, so DuckDB is obviously, you run it on your local machine, maybe you run it in EC2, maybe you're running it in Lambda functions, that type of stuff. MotherDuck is taking that library and building a cloud service around it. And kind of our kind of first bit that we're describing and thinking about here is MotherDuck as a data warehouse. And so we're basically taking a lot of the things that in DuckDB um, were excluded, like security and governance and things like that, and finding ways to add it back in, something that you need to really run in an enterprise, but in a way that does not, you know, make the same trade-offs that led to that feature being dropped in the first place, which is a lot of those things are slow. Like I think
Hmm.
in there was a really good lecture that Andy Pavlo over at CMU gave, and he was talking about in like traditional OLTP databases, roughly 90% of the compute time is things other than executing the query, right? And
Yeah.
so DuckDB says, what if it was 100% of the compute time was just executing the query? Well, that means like things like, you know, what tables you have permission to in the catalog and stuff like that. No, it's like if you have it in the catalog, you can query it. There's no extra granularity of permissions there, and so we have to figure out how to kind of add those pieces back and do it in an elegant way with really nice abstractions.
Makes
So
sense.
that's kind of the main thing we're doing, and then there's some really cool stuff you can do also because it's so easy to install MotherDuck with DuckDB. You just type in md colon, and away you go. And
Yeah.
what that means is you can do things like run a query locally, then ship the results into MotherDuck really easily, or join data that's local to data that's in the cloud. We see that a lot of times in like CRM type use cases. Maybe you get a list from someone of like leads from a conference. You say, hey, are these people already in our CRM? And like that CRM data is in your data warehouse, but this, you know, and nothing matches, like the formats of the emails or whatever are not the same. So you have to do all this like normalization work to compare it, and you can just do all that kind of in a DuckDB workflow with MotherDuck, which is very cool.
Cool. So MotherDuck is the cloud data warehouse. DuckDB is my like local in process thing.
That's
So
right.
if I was like a SQLite user, is that sort of like my local SQLite versus like, I don't know, what's a hosted SQLite or like a
There's like
database?
Suro and some others.
Yeah.
Yeah, yeah. There's definitely people who are doing it. I don't know if there's a perfect analog there. I think about, you know, it's more like uh yeah, I don't know if there's a good kind of analog where it's like, oh, this thing that you can take locally and move it into the cloud. I guess maybe Docker is kind of a way to think about that, right? Like the thing runs locally, you just take that package and you run it on a way bigger machine, right? Um,
Sure.
that's kind of the metaphor, I guess, with DuckDB and MotherDuck is it's kind of like Docker.
Cool. So what are those like main pieces value add that you get? It's storage. I'm assuming there's some storage, there's more compute. You mentioned some enterprisey things. What are like if
Yeah,
you're going to someone and you're like, no, like these are the value adds. These are, or people tell you, what do people tell you? Like, I'm using MotherDuck because
yeah, it's a good question. I think, you know, the main thing is DuckDB is kind of single player, right? So like I can do all this really great work on my laptop, and then I can, you know, ship the final result maybe to an Excel file or a CSV, but I can't really share that process flow with someone else. And so it brings the multiplayer piece to it, where I can just say, hey, like, you know, it's a database, just like I don't know, like Postgres. Like now other users can have credentials and log into it and interact with the data. Um, I think, you know, so that's part of it. I think another part of it is kind of like you know, we hear folks are like, hey, I'm running DuckDB, but like my compliance team is like, we need to pay someone for this. So like, can we use your thing to like, you know, as an in there? It's like, yep, sure, absolutely. And so yeah, so we had a bunch of stuff, you know, that you would expect in there. There's also a bunch of, you know, integrations we're building kind of to MotherDuck and then also DuckDB, like what we built with you all at Bytewax. Um, so yeah, it's kind of like it really just takes advantage of all the kind of fun things of DuckDB and makes them in the cloud. I would say the last piece that we see is like because we have kind of built MotherDuck to run DuckDB on really big machines. There's certain people who are like, hey, like this workload is too big for my local
Mhm.
machine. You know, let's can I run this in MotherDuck? And the answer to that is of course yes.
Yeah.
Two, and that allows lots of really nice workflows around kind of like what in the past I would call big data processing, but now it's just like data processing or small data.
Yeah.
Yeah,
Smallish
yeah,
data on
yeah,
I don't know, how a terabyte of memory machine.
yeah, yeah. Right, exactly. I mean, you know, I think the biggest nodes you can get on AWS right now have 32 terabytes of RAM. Um,
Insane.
Obviously, like DuckDB doesn't quite operate super well at that scale yet, but like those those nodes are actually built for SAP HANA, which is also a in process analytical database,
Yeah.
or in memory, excuse me, not in process, but in memory analytical database. So I think that's a kind of a good sign of, you know, that's the future is MotherDuck able to scale at kind of, you know, huge in memory workloads.
Yeah. So SAP SAP HANA mentioned as an analytical database, but what are some of the, what are some of the others that are out there that you get compared to ClickHousey things,
Yeah,
Snowflake?
sure,
Like, there's some of these like flavors of the week. Why MotherDuck? Like not salesy, but like why,
sure.
ultimately, why would you use MotherDuck over Snowflake? Aside from paying way too much, no, I'm just kidding. For
No, I mean, I think
Snowflake.
first off, those are great databases. Snowflake, Databricks, Redshift, ClickHouse.
Is
Like,
Redshift great? Is it? Is it? Has it
look,
changed
I'm not.
since
I'm
2016? Because I used it in 2016 and it was like okay because it was 2016, but it was still a pain. Like migrating, like up, like increasing the size of Redshift, non-trivial.
correct. I think really how we're thinking about this is there's two things. The reality is the data that you're actually querying on a day-to-day basis doesn't need the horsepower that you get from a massively parallel processing type database like Databricks or Snowflake.
Hmm.
So in general, you really just need a few. You really just need a pretty small set. And Jordan, the CEO of MotherDuck, actually wrote a really nice piece on this called "The Redshift Files" on our blog that kind of frames out, hey, like maybe you don't need to over provision all these resources. You can actually run it kind of on a single node.
Yeah.
Um, so I think that's the first thing, and I think the second thing is because we're so closely tied to DuckDB, um, we expect that they will continue their kind of best in class development trajectory, which means we
Mhm.
get to take advantage of that and bring that all to our users. Just to give you an example, if you DuckDB tracks their own benchmarks, and for things like reading flat files, in the last 3 years, I think they've increased like 10 to 20x in throughput.
Yeah.
Um, and that's like not, and that's like controlling for hardware. So, and we believe there's more juice to squeeze there, and they will continue
Yeah.
to do it. The thing that I always kind of like joke about the DuckDB stuff is like the fastest way to get them to work on the feature that you want them to work on is show them a chart where they're number two. Um,
Yeah. Yeah.
so like they're very motivated to be the fastest and be the best experience. And so we want to sell to people who want to be part of that, right? Who are like, hey, like it's important to me that I get to use this really cool tech. And that's not everybody, but like um I think that we believe the trajectory and then kind of how those dots will connect will just continue to lead to just a more awesome experience every day for MotherDuck users.
Yeah.
And we're very happy to kind of bring that reality to fruition.
Cool. There was the one billion row challenge, the one
Yeah.
VRC challenge in like January that Gunnar put out. And
Yep.
I remember at some point someone was like, everyone was trying these different things. It was still like, minutes, like hadn't gotten to like, oh, I like
Hmm, hmm.
did in the second half. Someone was like pip install DuckDB, load DuckDB, run the average thing or whatever per sensor station or whatever it was. And it was like 23 seconds out of the box. Like the IO
Yeah.
is just insanely optimized. It feels
Yeah.
like also process
Yeah.
utilization in DuckDB, which is, I mean, it's so great to have a symbiotic relationship where there's someone who's just like, I'm going to just do performance every day, all day, which they love to do.
Yeah.
Everyone's like, I'll work on performance. And
Totally.
you all can like serve the customer group. It sounds like
Yeah.
it's a symbiotic
Yeah.
relationship.
Yeah, definitely. I mean, we have a great relationship with them. They're building something really cool, and we get to be a part of that. And I think also add our own flair to it, which is really great. And yeah, it's a lot of fun.
Yeah, cool. Well, let's shift gears to streaming because we're all here for streaming, or we are. Um, we're
Yep,
dragging you in with us.
I
So
know, I know.
streaming in the data warehouse, generally they're thought of as like streaming ends where the data warehouse begins, or at least,
Sure.
most of my experience, it's like
Yeah.
majority of people only interact with a stream of data when they're like, I need to ingest this thing to somewhere else so I can do some cron based activity on it or use some
Hmm,
scheduler.
hmm, hmm.
Um, is that the future is like, what does the future look like? You're sitting in this perspective where you're always talking to people about data warehousing, seeing what they're doing. It's really cool tech. So you're probably talking to people who are very innovative or like forward leaning. Like how do you see streaming fit into that picture?
Yeah, that's a really good question. I think you mentioned earlier, like it has insanely fast file IO. And so what that means is you can do kind of fun things where you can stream into files and then just like query them with DuckDB in an almost, there's latency. Like I don't want to say it's zero latency. Like it's not true streaming really, but you can take advantage of it and like not have to worry about kind of building all the streaming primitives that you might necessarily need in another database, right? So, like for example, DuckDB does not have this notion of like materialized views, which are like key parts of stream processing in other databases, where you kind of just you push data into some table and then it works its way through the other tables. And because generally we're thinking more about analytical workloads that are more batch driven. We're not there, and I don't know where our where we'll get to. But what we found is that you can keep a very small section of let's say the most recent 15 minutes, and you can query that query that with DuckDB, get really fast kind of IO, and then keep a older partition that you just union all of the previous data, and now you kind of get this full view of the stream.
Hmm.
Um, so that's kind of how we're handling it. What it will look like in the future, is anyone's guess. I think the best performance that we see in general with DuckDB, which is not surprising, is kind of handling large row groups and kind of micro batching versus
Yeah.
atomic one row at a time
Yeah.
streaming. Like that's just that pattern is not a happy pattern for us, and like I'll be honest with that. But if you're getting 10,000 or 100,000 rows every second or every minute and like writing those into files, we can just pick those right up and read straight in, and it's so fast. Like it's so optimized for reading CSV or JSON or Parquet, Delta, Iceberg, etc., that you can kind of just not think too much about it, and it just works, which I think is a lot of the magic of what you get with DuckDB and MotherDuck. Is it's just like, okay, like I could, like you're talking about the streaming challenge that Gunnar put out, which, or not that, that's not streaming, the 1 billion row challenge, which is really interesting to follow along with, where it was like, you saw the solutions that were the fastest, and it was basically like, leet code, like extra hard, like,
Yeah. Like
like
insane.
solutions. You're like, wow, that's really cool. I'm so cool that someone can do that. It's like, great. They did it in like, 5 seconds, and it's like, or you just pip install and it takes a little bit longer, but like it's way faster than what we had, other kind of out of the box options. So
Yeah.
yeah, I think like we'll kind of see where it goes, but we are definitely seeing that like you can make it work, and it's not even like you can make it work. It's more like you can just like not think about it, or maybe think about it just a little bit, and we can guide you, and it's like, oh well, this is a great experience now that I think about it this way. Yeah.
Yeah. One thing I think that might be interesting, like, I mean, the idea for, analytical engines is that because uh, the sum of the parts, or like the sum of that data provides more information, like that context is what's important.
Yeah.
Um, maybe like maybe it's that the data warehousing um, moves more into the streaming storage layer. Like, query a topic instead, because at the end of the day, the analytical queries probably don't need to be resolved every 10 milliseconds. Like, what you really actually want to do is like maybe ad hoc query that raw data before you design a table. So I think there's also like maybe there's like the data warehousing analytical stuff moving down there that would be interesting. Like, hey, I want to ad hoc query a Kafka topic, and all the partitions and how data moves into well, whatever the interim format so that it can be queried by the
Hmm.
analytical engine. Having that all gone is kind of interesting. And
Yeah.
people have worked on it in the past, but then that gets abused as like, yeah, but then you can do streaming ETL with the same thing. And you're like, yeah, but can you really? I don't know. But just the ad hoc, like a notebook that can query. Imagine MotherDuck could like have a Kafka connection, and you write a MotherDuck query against that, Kafka topic, and it just sort of like resolves the query for the range of data you want. Would be kind of cool, moving analytical into that storage.
Yeah. I mean, I think we'll like I said, we'll see how it goes. Obviously, we've built a really cool integration with you all, so like, there's opportunity to think about
Yeah.
things like that. And
Wait, so
then
we can do that. We can do
yeah, yeah,
that.
exactly. Yeah, I think it's just, yeah, it's just kind of making sure, like, you need to understand what you're trying to accomplish a little bit. And I think like that's kind of, um, you know, once you understand that, and then you can kind of work back from first principles on where you need to put streaming. I think that really helps in these use cases.
Yeah. Okay, well, let's start to move forward here. We got some stuff to show off. Before we go there, I wanted to ask one question about SQL. We're out of the SQL world these days in Bytewax, but
Hmm.
what's the silliest or coolest or most nightmarish thing you've ever built using SQL? They're like, wow, someone else is maintaining this for me because I left that previous job. I'm so sorry. Or,
I mean, so my background, I did a lot of work in SQL Server, and SQL Server can do everything. It has its own cron built into it. It has stored procedures, has its own email server. Um, so like
wow.
at a previous company, for example, all of our emails that got sent to customers, like from our application, were generated by a stored procedure.
Wow.
Um, so like, but that's like, I didn't write that. That was just kind of like, that's just what people do with SQL Server. But I think, I don't know, like, I'm kind of a fan of doing like ML workloads in SQL. So things like clustering, or I have a personal project I work on called MDS in a box. That is a NBA and NFL predictive model, and that's
Yeah.
almost all in SQL. So um,
Cool.
lots of fun cursed things are possible. Yeah.
That's rad. I have heard of the NDS in a box. I haven't actually poked around with it myself, but I should go check it out.
Mhm.
Well, should we shift gears, Laura? Do you want to share what you've been working on with the MotherDuck team?
Yeah, so hi everyone, Laura, and I had a chance to work along with the MotherDuck team on an integration that enables us to write MotherDuck tables or write tables to MotherDuck and DuckDB using Bytewax. So that's where I'm very excited to talk to you about. What we did together is we built a connector. We built a sink along with an operator that allows you to write whatever data you've transformed. And I think this ties to this idea of how should I perform my data aggregations, or how should I manipulate my data? Is it through SQL or is it through Python? So my background is in data science, and I was way more used to using Python to transforming data and then storing it elsewhere. So I'm going to be taking that approach. So
Cool.
I'll share with you what we put together. So we put together this as an installable module. So this is a sync and operator for DuckDB and MotherDuck, so it is compatible with both of them. And we've made the installation as easy as possible by simply doing pip install bytewax DuckDB. It'll install bytewax and DuckDB as well. So here it is. So in here, I'm assuming I already have a MotherDuck token, so I won't go through the process of creating one, but essentially, if you go to MotherDuck, you can go to your organization and create a new token. The token is what will enable me to connect to the cloud-based instance. And in here, I've already entered my token, so I won't go through that again. But here we have two examples. So what I wanted to do is I wanted to do some simple batch processing with Bytewax and DuckDB. So the way this works in Bytewax is we typically have these data flows, which are DAGs. And I always start, this is always the first step. I initiate a data flow instance and I give it a name. And then I can chain different operators. And by chaining the operators, I transform how the data transforms. So I'll have my input operator. In this case, all I'm doing is iterating through the numbers 0 through 49. And in this case, that's operator first. And then the second operator I'm going to apply is the map operator, which is going to apply this create dictionary function. And all this is doing is creating this tuple. So in this case, what I'm going to be doing is I'm going to consider this my first batch of data. And then the data is going to have the values 0 through 49 and just the word Alice. Okay, so when I create this, all I'm going to have is a tuple. And before I show you the DuckDB one. So if I go here, op.inspect output, and I'm going to show you the dictionary stream. So when I run this, this is just going to return this tuple that has the batch ID and then a dictionary containing the values. Now, this is a very important assumption that we made, where we're always, whenever we are going to write a batch of data to either DuckDB or MotherDuck, we're always going to expect this data structure containing the batch ID and then the data itself. So I'm going to get rid of this inspect command, and I'm going to now use the DuckDB operator that we created. So in this case, as before, typically we have some kind of name for the operator. So if we think about this in terms of DAG, I'm building a directed acyclical graph where I have my input, I have my nodes. So each of these is going to be a node. So I have my input node, my dictionary node, and my output node. Now this is the DuckDB operator. This is going to be named out. It's going to take us input this dictionary stream, which is simply this tuple. It's going to be this batch of tuples that contain the data that I want to write. And then in here, I'm going to write it locally first, and then we'll write it to MotherDuck. So I'm going to call this example table. I'm going to create a table called example table, and I'm going to give it 2 columns. I'm going to have the column ID, which is going to contain integers, and the column name. Now, when I run this, what's going to happen if I go hit refresh is a sample.docdb file has been created. So I can then go ahead and inspect that the table was successfully created on the DuckDB file. So if I go and make a connection to sample.docdb, I can go ahead and see that the data is there and that the table has been created. So it ties back to this idea of I didn't have to set up any credentials to a server. I simply ran pip install, and I can now have a little DB in my Colab. Now, the next phase, of course, is we wanted to make it compatible with MotherDuck as well. So what we did in here is I have a second data flow. So again, I initialize my data flow. This time I put it DuckDB names and cities. So this time I'm going to have a table that has these names and these cities, and I'm just going to add a random age, and I'm going to call this batch 1. So batch 1 is going to have an ID. In this case, it's going to be a number from 0 to 49. I'm going to have the name, the age, and then the location. So the age is going to be randomly created. Now, in this case, all I need to do is replace the path that I had used here before, sample.docdb, with the path containing the MotherDuck, your MotherDuck instance. In this case, this MD token was something that I passed as a secret. If you're working with something like a Python script, or you want to schedule this, or you want to run it on the terminal, you can use environment variables instead. So when I go ahead and run this in here, I'm again going to go ahead and create my dictionary with my batches. I'm going to go ahead and output the data. And then if I go ahead and check, I am now connecting to this MotherDuck instance, and I can confirm that the data has been created and stored as a table. So that's it for now. So with this, we're able to both combine the power of streaming with the ease of use of DuckDB and MotherDuck. And that's about it.
Cool. I mean, this
That's
is what's so
awesome.
cool about DuckDB and MotherDuck and Bytewax is you run everything in process. You can write tests. You can test it locally. You can mess around. You can develop really fast, and then boom, go to production.
That's right. That's right. It's very, that's really cool demo. Thank you, Laura.
Happy to. It was a lot of fun, and hopefully we get a chance to build some more cool demos with the more interesting data sets in the near future.
Absolutely.
I got one. Well, I don't know if there are questions on Laura's demo. Otherwise, I have a question, or maybe you have something you can help us with about a pun between ducks and bees, where the MotherDuck is the most pun forward company I think I've ever met in the tech industry. Definitely in the infrastructure, software technology infrastructure. And like we set a standard at one point, like this was like a year ago, and Ollie, who's not on this call, and I were talking, and she was like, the bar's here. It's called MotherDuck, and this is where we could be. And we've never made it, but you know, we do our best to spread the joy of the chunky bee and as many bee puns as we can.
Yeah, unfortunately, I don't have a good duck and bee combination one. We may have to workshop that and for the next blog post. Maybe that's what we
I
can
came up with
make that a
one
target.
where streams meets quacks. I don't know if that one's a good one, but that's the one I
All
could
right,
come up
that's
with.
pretty good. That's close.
Every duck will travel on a stream into a lake. We need to put data lakes. If it was like data lake house, you're
Yeah,
like,
yeah,
uh,
yeah. There's something there. We'll find one. We'll find
the
one.
data streams into the duck pond.
Yeah. Something. I don't know. It's funny.
All right. Well, anything else?
That's it. So yeah, this Bytewax DuckDB module is available commercially. So if that's something that that the community is interested in, I think it is one of those things that we're very eager to put out as one of the new modules and connectors that we have made available.
Source available commercially.
Source available commercially. Thank you so much.
Yeah. Which, whatever that means. It means you can use it locally. When you go to production, you're supposed to have a license.
Yeah.
There's a whole lot of downloads of our commercially licensed connectors. So I don't know. Yeah, we'll see.
Interesting. Yeah. Cool.
Okay, cool. Well, thank you so much for joining us, Jacob.
Yeah, it's
Thanks,
been great.
Laura.
Thanks for having me here. I'm really excited to see where this takes us. And, as someone who comes from the kind of more batch world, I'm excited to learn more about streaming and how I can, make it all work in MotherDuck and with Bytewax is very cool.
You know, the dirty little secret to streaming is that you batch things as much as possible to get the throughput you need while still meeting the latency requirements. So like, for example, in Bytewax, between every function, everything's batched up so that we can ship it over, serialize only once, do all these. And it's the dirty little secret behind every streaming system is a lot of batch.
Yeah, that makes sense. I mean, it's about, the one thing that I like noticed and as like my pipelines got more sophisticated, was that like you get to a tipping point where like the guarantees you're trying to provide on the data basically mean like you should just implement like something that looks like streaming instead of batching. So it's like, you got to figure out where that breakpoint is on your, flow. So anyways.
Cool. All right. Well, we'll catch you later.
All right. Sounds good. Thanks
for joining. Bye-bye.
All right. Bye.